Hi, everybody. It's Professor Mitchell, continuing with Chapter 5. In this video, we'll look at Section 5.5 on permutations and combinations. In this section, we'll look at permutations, combinations, the permutation formula, factorials, and finally the combinations formula. And I will also show you how these formulas are probably built into your calculator and how to use your calculator to evaluate those formulas. All right, so starting with a permutation, given a set of n objects, a permutation of n objects taken r at a time is an arrangement of r of the n objects, and here come the most important words, in a specific order. The notation for a permutation is p parentheses n comma r, which I will sometimes read as p of n r, which is the number of permutations of n objects taken r at a time. So here's an example. How many words, and in this course, whenever we talk about words, we're just talking about strings of letters. They don't have to be real words. How many words of two distinct letters can be formed from the letters A, B, and C? So the number of objects is n, which is 3. The number of objects taken at a time is r, which is 2. So notice that in order for this to work, r has to be less than or equal to n. It can't be bigger than n. So listing the possibilities are AB, AC, BA, BC, CA, and CB. Note that you could solve this problem using the multiplication principle or a tree diagram. You have 3 choices for the first letter and then 2 choices for the second letter. Notice it does say the letters are distinct. Therefore, P of 3, 2 is equal to 6. Note that the word AB is different from the word BA. All right, compare that to a combination, which starts off sounding similar. Given a set of n objects, a combination of n objects taken r at a time is a selection of r of the n objects, and here come the important words, with order disregarded. The notation for a combination is C of n comma r, and I almost always read this as n choose r, which is the number of combinations of n objects taken r at a time. All right, so for example, how many 2-member teams can be formed from a group that has 3 members, A, B, and C? The number of objects is n equals 3. The number of objects taken at a time is r equals 2. And the possible teams are A and B, A and C, or B and C. Therefore, 3 choose 2 is equal to 3. Note that the team AB is the same as the team BA. Otherwise, this is a lot like the permutation example we talked about, right? Okay, so let's talk briefly about the formulas, but I am not worried about you doing these formulas by hand. You can do them on the calculator. So P of n comma 1 is equal to n. Suppose that you had 10 books, and the question was, how many ways can you choose one book and put it in order? All right. It almost doesn't even make any sense. There's one book, therefore there's only one way to put it in order. So P of 10 comma 1 would be 10. Nothing special about the number 10. For any number n, P of n1 would be equal to n. P of n2 is equal to n times n minus 1 by the multiplication principle. So again, if you had 10 books and you wanted to choose 2 of them, maybe to read on your vacation, and let's say that you were thinking about the order, which book are you going to read first? There are 10 choices for the first book and 9 choices for the second book. In general, n choices for the first, n minus 1 for the second, and so on and so on. All right. So one way to write the formula for P of n comma r is like this: n times n minus 1 times n minus 2, all the way down to n minus r plus 1. It's a little confusing why you need the plus 1 there. All right. And I'm not going to take a lot of time to explain it right now. It's something you can think about, especially since I am going to encourage you to just evaluate this formula on your calculator. Okay, so I'm going to use the calculator to do this problem. 8 horses are entered in a race in which a first, second, and third prize will be awarded. Assuming no ties, how many different outcomes are possible? And you know what? I think I will just switch right over to the calculator. Now, I happen to have a graphing calculator, but it's very similar on the scientific calculator. I'll try to describe to you how it works. On the graphing calculator, what you're going to do is press Math, which brings up a menu that looks something like this. This is a graphing calculator app that's supposed to look like either the TI-83 or TI-84. If you actually have a TI-83 or TI-84, it will look similar. It won't look exactly like this. See across the top where it says Math, and then NUM, and then CPX, and then the last one, PRB. PRB stands for probability, and that's the one I'm going to pick. Oh, wait a minute. Before I do that, I'm so sorry. I need to press the number 8, which is the value of n. Now I'm going to press Math, and I'm going to go over to PRB. And since this is a permutation problem, I'm going to select the number 2, NPR, and then I'm going to put the number 3. So it turns out that P of 83 is equal to 336. I'll just show you briefly how you would do that using the formula. So you have 8 choices for which horse comes in first, 7 for which comes in second, and 6 choices for which horse comes in third. You get the same answer. All right, so let's go back to the presentation. All right, so there is that answer. So now they're going to introduce factorials, which will give us a kind of a more compact way of writing the formula, and also the formula for combinations is coming up. So 1 factorial is equal to 1. 2 factorial is equal to 2 times 1, which is 2. And in general, n factorial means start with the number n and multiply by every smaller number until you get to 1. So this only works for whole numbers. Note n factorial, the joke, probably again, tired old cliche joke that I like to use is that this notation is not read n, but is read n factorial. Now, there's one kind of important thing that I don't see mentioned here, and I think I had better mention it now because it very well could come up soon. Let's see, get a text box here. We need to have a way to calculate 0 factorial. The way that I just described, start with that number and multiply by every smaller number until you get to 1, doesn't work with 0 because 0 is already less than 1. So what we say about 0 factorial is that by definition, which is just another way of saying because I said so, 0 factorial is equal to 1. That is by definition. Okay. It turns out it makes a lot of sense for 0 factorial to be 1. Believe it or not, I may talk about that a little bit later. All right, so let's move along here. Okay. I'm kind of tempted to have you ignore this form of the formula. In fact, I think that's exactly what I'll do, except just to point out that it is P of n comma r divided by r factorial. If you would like to know why that is, that would be a good discussion question. I would be happy to explain that in the discussion. Okay, so the board of directors of a corporation has 10 members. In how many ways can they choose a committee of 3 board members to negotiate a merger? So I want to point out that this is different from choosing a chairperson, a vice chairperson, and a secretary, because in that case, the order in which the people are chosen matters. The first person is the chairperson, second person is the vice chairperson. In this case, the committee of 3 people, they have no specific roles. So picking Alice, Charlie, and Fred is the same thing as choosing Fred, Alice, and Charlie. It's the same committee. So I am going to switch back over to the calculator. All right, so this time n is 10 and r is 3. So I'm going to start by putting in the number 10. And then I'm going to press math. By the way, if you have a TI-30, for example, scientific calculator, you should have a button right on your calculator that says PRB. So hopefully you have your calculator in your hand. Look down at your calculator, look for the PRB button. And at this point, you're going to press that button. I'm going to press math and then go to PRB. If you have a scientific calculator, when you press the PRB button, you're going to see 3 choices across the top of your screen. You're going to have NPR, NCR, and also N factorial. You're not going to have all these other ones. And I can't say that I have ever used any of these other ones. All right, so this time I'm going to pick number 3. And then I'm going to put a 3 there. Okay, so it turns out that 10 choose 3 is equal to 120. Remember they said a moment ago that 10 choose 3 is supposed to be the same thing as P of 10, 3 divided by 3 factorial. To get factorial, that's also under PRB. And on this calculator, it's number 4. So notice that gives me the same answer. All right, back to the presentation. Excuse me for just a second here. Okay, get rid of that. Oops. Okay. So the number of objects is n equals 10, r is 3. Okay, so this is another way to calculate it if you, for example, don't have your calculator handy. We can move on from that. And then we are actually done with section 5.5. So the number of ordered arrangements, each called a permutation, of n objects taken r at a time is, I'm just going to say P of n r. Figure you'll do that on the calculator. The number of unordered arrangements, each called a combination of n objects taken r at a time, is C of n r, which again I will usually read as n choose r. And that's going to do it for section 5.5. We'll see you next time.